Fact 1. The circumstellar habitable zone, the Goldilocks region around stars. The search for extraterrestrial life is one of the most exciting and challenging endeavors in modern science. A key concept in this search is the circumstellar habitable zone, CHZ, also known as the Goldilocks zone. This is the region around a star where the temperature is just right for liquid water to exist on the surface of a planet. Liquid water is considered to be essential for life as we know it. It acts as a solvent, allowing for the transport of nutrients and waste products within cells. It also participates in many of the chemical reactions that are necessary for life. The location of the circumstellar habitable zone depends on the size and temperature of the star. Hotter and more massive stars have larger and more distant habitable zones than cooler and less massive stars. The inner edge of the habitable zone is determined by the point where a planet would receive too much radiation from the star, causing water to evaporate and escape into space. The outer edge of the habitable zone is determined by the point where a planet would receive too little radiation from the star, causing water to freeze. The Earth is located within the Sun's habitable zone. This is why liquid water is able to exist on our planet's surface. The concept of the circumstellar habitable zone is a useful tool for identifying potential targets in the search for exoplanets. Astronomers are focusing their efforts on finding planets that are located within the habitable zones of their stars. However, the circumstellar habitable zone is not the only factor that determines whether a planet is habitable. Other factors, such as the planet's atmosphere, magnetic field, and geological activity, can also play a role. For example, a planet with a thick atmosphere could trap heat and allow for liquid water to exist even if it is located outside the traditional habitable zone. Conversely, a planet with a thin atmosphere or a weak magnetic field could be uninhabitable even if it is located within the habitable zone. Despite these complexities, the circumstellar habitable zone remains an important guide in the search for extraterrestrial life. As we continue to discover more exoplanets, we are sure to find some that are located within the habitable zones of their stars, increasing the odds of finding a planet that is capable of supporting life. The circumstellar habitable zone, or Goldilocks zone, is the region around a star where liquid water can exist, considered crucial for life. Its location depends on the star's size and temperature. While not the only factor for habitability, it guides exoplanet searches. It's like a cosmic sweet spot where conditions are just right for liquid water and potentially life to thrive. Fact 2. The Great Void, a cosmic emptiness on an unimaginable scale. In the vast cosmic web of galaxies, filaments, and voids, there exists a region of space so devoid of galaxies that it has been dubbed the Great Void. Also known as the Boötes Void, this colossal emptiness spans an astonishing 330 million light-years in diameter, making it one of the largest known voids in the universe. To put that size into perspective, the Great Void is so large that our entire Milky Way galaxy would be a mere speck of dust within it. If you were to place the Milky Way in the center of the Great Void, you would have to travel hundreds of millions of light years in any direction before encountering another galaxy. The Great Void was discovered in 1981 by astronomer Robert Kirshner and his team, who were mapping the distribution of galaxies in the constellation Boötes. They were surprised to find a vast region of space that contained virtually no galaxies. The expected number of galaxies in a region of space the size of the Great Void is estimated to be several thousand. However, astronomers have found only about 60 galaxies within the void. Most of these galaxies are located near the edge of the void, and they appear to be moving away from the center. The origin of the Great Void is a mystery. One possibility is that it formed from the merger of smaller voids. Over billions of years, gravity could have pulled smaller voids together, creating a larger and larger empty region. Another possibility is that the Great Void formed due to the action of dark energy, the mysterious force that is causing the universe to expand at an accelerating rate. Dark energy could have pushed galaxies away from the region, creating the void. The Great Void is not completely empty. It contains a small amount of gas and dust, as well as some dark matter. However, the density of matter in the Great Void is much lower than the average density of the universe. The Great Void is a reminder of the vastness and emptiness of space. It also raises questions about the distribution of matter in the universe and the forces that shape the cosmic web. The Great Void is a massive, galaxy-free region of space, spanning 330 million light-years. Its origin is a mystery, possibly formed by the merger of smaller voids or the action of dark energy. It highlights the vast emptiness of the universe. It's like a cosmic blank canvas, an immense emptiness in the grand tapestry of the universe. Fact 3. Dark matter and dark energy. Dark matter and dark energy are two of the biggest mysteries in modern cosmology. They make up the vast majority of the universe, yet we know very little about their true nature. They are called dark because they do not interact with light or other electromagnetic radiation, making them invisible to our telescopes. Dark matter was first proposed in the 1930s by astronomers who observed that galaxies and galaxy clusters were rotating faster than they should be based on the amount of visible matter they contained. In other words, galaxies were spinning so fast that they should have flown apart long ago. The only way to explain this was to assume that there was a significant amount of unseen matter providing extra gravitational pull. Dark matter does not emit, absorb, or reflect light, making it extremely difficult to detect directly. Its presence is inferred through its gravitational effects on visible matter. For example, the gravitational lensing effect, where light from distant galaxies is bent and distorted by the gravity of intervening dark matter, provides strong evidence for its existence. Scientists believe that dark matter makes up about 85% of the total matter in the universe. It is thought to be composed of some kind of exotic particle that does not interact with ordinary matter through the electromagnetic force. Many different types of particles have been proposed as dark matter candidates, including weakly interacting massive particles, WIMPs, axions, and sterile neutrinos. However, none of these particles have yet been directly detected. Dark energy is an even more mysterious substance than dark matter. It was discovered in the late 1990s when astronomers observed that the expansion of the universe was accelerating. This was a surprising discovery because it was previously thought that the expansion of the universe was slowing down due to the gravity of all the matter it contained. The accelerating expansion of the universe implies that there is some kind of repulsive force counteracting gravity. This repulsive force is attributed to dark energy. Dark energy is thought to make up about 68% of the total energy density of the universe. The most popular explanation for dark energy is the concept of the cosmological constant, which is a constant energy density that fills all of space. The cosmological constant was originally proposed by Albert Einstein as a way to keep the universe static, but he later abandoned the idea when it was discovered that the universe was expanding. However, the cosmological constant has been revived as a possible explanation for dark energy. Another possibility is that dark energy is not a constant, but rather a dynamic field that changes over time. This is known as quintessence. Quintessence could be a scalar field that permeates the universe and exerts a negative pressure, causing the expansion to accelerate. The nature of dark matter and dark energy is one of the biggest challenges facing modern physics. Understanding these mysterious substances is crucial for understanding the evolution and fate of the universe. Scientists are using a variety of techniques to try to detect dark matter and dark energy, including direct detection experiments, indirect detection experiments, and cosmological observations. Direct detection experiments aim to detect dark matter particles directly as they interact with ordinary matter in detectors. Indirect detection experiments look for the products of dark matter annihilation or decay, such as gamma rays or cosmic rays. Cosmological observations, such as measurements of the cosmic microwave background and the large-scale structure of the universe, provide constraints on the properties of dark matter and dark energy. The search for dark matter and dark energy is a long and difficult process, but it is one of the most important endeavors in modern science. Unraveling the mysteries of these dark substances will revolutionize our understanding of the universe and our place within it. Dark matter and dark energy are mysterious substances that make up the vast majority of the universe. Dark matter provides extra gravitational pull, explaining why galaxies don't fly apart, while dark energy is responsible for the accelerating expansion of the universe. Scientists are actively searching for these substances, hoping to unlock the secrets of the cosmos. It's like the universe is hiding a massive secret, and we're on a cosmic treasure hunt to find it. Fact 4. The Nemesis Hypothesis. Did a companion star drive extinctions on Earth? For decades, scientists have pondered the cyclical nature of mass extinction events on Earth. Roughly every 26 to 30 million years, there seems to be a spike in the extinction rate of various species. This pattern has led to numerous hypotheses attempting to explain the cause. One of the most intriguing and somewhat controversial being the Nemesis Hypothesis. The Nemesis Hypothesis proposes that our Sun has a distant, undiscovered companion star, dubbed Nemesis, which follows a highly elliptical orbit that takes it far out into the Oort cloud, a vast reservoir of icy bodies at the edge of our solar system. As Nemesis approaches the inner solar system during its orbit, its gravitational influence disrupts the Oort cloud, sending a barrage of comets hurtling towards the inner solar system and potentially colliding with Earth. This bombardment of comets could trigger mass extinction events by causing widespread wildfires, impact craters, and long-term climate changes. The impact events would inject massive amounts of dust and debris into the atmosphere, blocking sunlight and causing a global cooling effect. The Nemesis hypothesis was first proposed in the 1980s by physicists Richard Muller, Mark Davis, and Pete Hutt. They based their idea on the observation that impact craters on Earth seem to show a similar periodicity to the mass extinction events. Despite its initial appeal, the Nemesis hypothesis has faced significant challenges. One of the main problems is the lack of direct evidence for the existence of Nemesis. Despite numerous searches, no such star has ever been found. Some astronomers argue that Nemesis could be a dim red dwarf or even a brown dwarf, making it difficult to detect with current telescopes. Others suggest that Nemesis may have already been ejected from the solar system due to gravitational interactions with other stars. Another challenge to the Nemesis hypothesis is the difficulty in establishing a precise periodicity for the mass extinction events. The fossil record is incomplete, and it can be difficult to determine the exact timing and severity of past extinction events. However, the Nemesis hypothesis continues to be a subject of debate and research. Some scientists have proposed alternative versions of the hypothesis, suggesting that Nemesis could be a planet or even a dark matter object. In recent years, new data from space telescopes such as Gaia have provided more detailed information about the orbits of stars in the solar neighborhood. This data has been used to search for evidence of Nemesis, but so far, no conclusive evidence has been found. Even if Nemesis does not exist, the Nemesis hypothesis has helped to stimulate research into the causes of mass extinction events and the potential threats posed by comets and asteroids. It has also highlighted the importance of understanding the long-term dynamics of the solar system. The Nemesis hypothesis suggests a distant companion star to our Sun periodically sends comets towards Earth, causing mass extinctions. While unproven and debated, the idea stimulated research into extinction causes and solar system dynamics. It's like a cosmic grim reaper, periodically unleashing destruction from the outer reaches of our solar system. Fact 5. The Fermi Paradox. The Fermi Paradox is the apparent contradiction between the high probability of the existence of extraterrestrial civilizations and the lack of contact with, or evidence of, such civilizations. Named after physicist Enrico Fermi, who famously posed the question in 1950, the paradox remains one of the most enduring and thought-provoking questions in astrobiology and the search for extraterrestrial intelligence, SETI. The reasoning behind the high probability of extraterrestrial life goes something like this. The universe is vast, containing billions of galaxies, each with billions of stars. Many of these stars are similar to our Sun, and many are likely to have planets orbiting them. Given the sheer number of potentially habitable planets, it seems statistically likely that life would have arisen on at least one other planet besides Earth. Furthermore, if life arose on another planet, it seems plausible that it could have evolved to become intelligent and technologically advanced. If such a civilization existed, it might have developed the ability to communicate with other civilizations or even to travel to other star systems. Given these assumptions, one might expect that the universe would be teeming with life and that we would have already detected signs of extraterrestrial civilizations. However, despite decades of searching, we have found no conclusive evidence of life beyond Earth. This is the Fermi paradox. There are many proposed solutions to the Fermi paradox, ranging from the plausible to the speculative. One possibility is that the conditions necessary for the emergence of life are much rarer than we currently believe. Perhaps Earth is a uniquely suitable planet for life, and the probability of life arising on any other planet is extremely low. This is sometimes referred to as the rare Earth hypothesis. Another possibility is that while life may be common in the universe, intelligent life is rare. Perhaps the evolution of intelligence is a difficult and improbable process, and that most life-bearing planets are inhabited by simple organisms. A further suggestion is that intelligent civilizations are common, but they tend to destroy themselves before they reach the point where they can communicate with other civilizations. This could be due to war, environmental destruction, or some other self-inflicted catastrophe. This is sometimes referred to as the Great Filter. The Great Filter proposes that there is some stage in the development of life, from its initial formation to becoming a spacefaring civilization, that is extremely difficult, if not impossible, to overcome. We don't know where this filter might be. It could be behind us, meaning we've already overcome it. It could be ahead of us, meaning we're likely doomed. Or it could be that it's a series of smaller filters that make the journey incredibly challenging. Another intriguing idea is that extraterrestrial civilizations are deliberately avoiding contact with us. This could be because they're afraid of us, or because they believe that contact with a less advanced civilization would be harmful. This is sometimes referred to as the Zoo hypothesis or the Prime Directive, a reference to Star Trek. The Zoo hypothesis suggests that advanced civilizations are observing us, much like we observe animals in a zoo, without interfering with our development. They may be waiting for us to reach a certain level of technological or social maturity before making contact. Yet another possibility is that our search methods are simply inadequate. Perhaps we are looking for the wrong kind of signals, or we are not looking in the right places. It is also possible that extraterrestrial civilizations are communicating in ways that we do not yet understand. We might be like ants trying to understand the internet. Some more speculative solutions involve the idea that advanced civilizations may have transcended our understanding of physics and reality. They may have found ways to travel through space and time that are beyond our comprehension, or they may have even moved into other dimensions. The Fermi paradox is not just a scientific question. It is also a philosophical one. It forces us to confront our place in the universe and to consider the possibilities and the challenges of encountering other intelligent life. It also raises important questions about our own future and whether we will be able to overcome the challenges that lie ahead and become a long-lived, spacefaring civilization. The search for extraterrestrial intelligence continues, with scientists using increasingly sophisticated telescopes and search algorithms to scan the skies for signs of life. Whether we ever find evidence of extraterrestrial civilizations remains to be seen, but the Fermi paradox will continue to be a driving force behind this search. The Fermi paradox highlights the contradiction between the high probability of extraterrestrial life and the lack of evidence for it. Numerous solutions have been proposed, from the rare Earth hypothesis to the Great Filter and the Zoo hypothesis. It's a deep question that touches on science, philosophy, and our place in the universe, pushing us to consider the challenges and possibilities of encountering other intelligent life. It's like the ultimate cosmic riddle with no definitive answer in sight. Fact 6: the Oklo Natural Nuclear Reactor. Deep within the Earth, in the Oklo region of Gabon, West Africa, lies an extraordinary geological anomaly, a natural nuclear fission reactor that operated spontaneously nearly 2 billion years ago. This remarkable discovery, made in 1972, provides profound insights into the conditions necessary for nuclear fission, the long-term behavior of radioactive waste, and the early geological history of our planet. The story begins with routine uranium mining operations. In the course of analyzing uranium ore samples, French scientists noticed something peculiar. The uranium 235 U-235 content was significantly lower than expected. In natural uranium deposits, U-235 typically accounts for about 0.720% of the total uranium. However, the Oklo samples exhibited U-235 levels as low as 0.600%, a depletion that couldn't be explained by conventional geological processes. Further investigation revealed that the missing U-235 had been consumed in self-sustaining nuclear fission reactions. The Oklo site contained multiple reactor zones, where controlled nuclear chain reactions had occurred over hundreds of thousands of years. These natural reactors represent a unique phenomenon, providing a real-world example of how nuclear fission can occur naturally under specific conditions. Several factors contributed to the formation and operation of the Oklo natural reactors. First, the uranium ore at Oklo was unusually rich, containing a high concentration of uranium. This was crucial for achieving criticality, the point at which a nuclear chain reaction becomes self-sustaining. Second, the Oklo site was located in a region with abundant groundwater. Water acted as a neutron moderator, slowing down neutrons and increasing the probability of fission. Third, the geological environment at Oklo was stable and well-contained, preventing the dispersal of radioactive materials. The Oklo reactors operated in a pulsed manner, cycling between periods of activity and inactivity. When a reactor was active, nuclear fission would generate heat, causing the water to boil away. This would reduce the neutron moderation, slowing down the reaction and eventually shutting it down. As the reactor cooled, water would seep back in, restoring the neutron moderation and restarting the reaction. This cycle continued for hundreds of thousands of years, with the reactors operating at an average power output of around 100 kilowatts. The Oklo natural reactors produced a significant amount of nuclear waste, including radioactive isotopes such as strontium, 90, cesium-137, and plutonium-239. However, the geological environment at Oklo proved to be remarkably effective at containing this waste. The clay minerals surrounding the reactor zones adsorbed the radioactive materials, preventing them from migrating into the surrounding environment. The Oklo phenomenon has provided valuable insights into the long-term behavior of radioactive waste. It has demonstrated that natural geological barriers can be effective at containing radioactive materials for extremely long periods of time. This information has been used to inform the design and construction of artificial nuclear waste repositories, helping to ensure the safe and secure disposal of nuclear waste. The discovery of the Oklo natural reactors also has implications for our understanding of the early Earth. It suggests that conditions favorable for nuclear fission may have been more common in the past, when the abundance of U-235 was higher. The Oklo reactors may have played a role in the thermal evolution of the Earth's crust, contributing to the planet's internal heat flow. The Oklo natural nuclear reactors are a remarkable example of the power of nature and the complexity of geological processes. They provide a unique window into the past, offering valuable insights into nuclear physics, geochemistry, and the evolution of our planet. They are a reminder that even in the most unexpected places, nature can surprise us with its ingenuity and its ability to create extraordinary phenomena. The Oklo natural nuclear reactors in Gabon were a self-sustaining nuclear fission reaction that occurred nearly 2 billion years ago. They provide valuable insights into nuclear waste containment and the conditions of early Earth. It's like a time capsule revealing a naturally occurring nuclear experiment from Earth's ancient past. Fact 7. Rogue planets, wanderers of the galaxy. In the vast expanse of the galaxy, there exists a hidden population of celestial bodies, rogue planets. These are planets that have been ejected from their star systems, wandering the interstellar void without a parent star to orbit. These nomadic worlds are thought to be surprisingly common, potentially outnumbering the stars themselves. Rogue planets can be formed in a number of ways. One possibility is that they are ejected from their star systems due to gravitational interactions with other planets or stars. In a crowded planetary system, planets can gravitationally bump into each other, leading to one or more planets being ejected into interstellar space. Another possibility is that rogue planets are formed in isolation from collapsing clouds of gas and dust that never become stars. Detecting rogue planets is extremely challenging, as they do not emit light of their own and are very faint. However, astronomers have developed several techniques for finding them. One method is to look for the gravitational lensing effect, where the gravity of a rogue planet bends and magnifies the light from a distant star. Another method is to search for rogue planets that are still young and hot, and therefore emit infrared radiation. So far, only a handful of rogue planets have been confirmed, but estimates suggest that there could be billions or even trillions of them in the Milky Way galaxy. This means that rogue planets could be more common than stars, making them a significant component of the galaxy's mass. The existence of rogue planets raises fascinating questions about the potential for life in interstellar space. Could rogue planets harbor liquid water oceans beneath their icy surfaces, warmed by geothermal activity or internal radioactive decay? Could life have originated on a rogue planet, or could it have been transported there from another star system via panspermia? Some scientists have proposed that rogue planets could even be habitable if they have a thick atmosphere that can trap heat and provide protection from cosmic radiation. These planets could potentially harbor subsurface oceans where life could thrive. The study of rogue planets is a relatively new field, but it is rapidly advancing as new telescopes and techniques are developed. Future missions, such as the Nancy Grace Roman Space Telescope, we'll be able to detect rogue planets more easily, allowing us to learn more about their properties and their potential for habitability. The discovery of rogue planets has expanded our understanding of the diversity of planetary systems and the potential for life in the universe. It has shown us that planets are not always bound to stars, and that they can exist in a variety of environments, even in the cold, dark depths of interstellar space. Rogue planets are planets ejected from their star systems, wandering the galaxy alone. They're thought to be numerous and raise questions about the possibility of life in interstellar space. It's like discovering a hidden population of celestial nomads drifting through the vast cosmic sea. Fact 8. The Boomerang Nebula. The Boomerang Nebula, located 5,000 light-years away in the constellation Centaurus, is the coldest known natural place in the universe. Its temperature dips to a staggering minus 272 degrees Celsius, minus 458 degrees Fahrenheit, just 1 degree above absolute zero, the point at which all atomic motion ceases. This makes it even colder than the cosmic microwave background radiation, the afterglow of the Big Bang, which sits at a balmy minus 270 degrees Celsius. The Boomerang Nebula isn't your typical nebula, a cloud of gas and dust illuminated by a star. Instead, it's a preplanetary nebula, a dying star in the process of shedding its outer layers. This shedding process is what creates the nebula itself, as the ejected material expands outwards into space. The star at the heart of the Boomerang Nebula is similar to our Sun, but nearing the end of its life. As stars like our Sun age, they eventually run out of hydrogen fuel in their core. This triggers a series of changes, causing the star to expand into a red giant. During this phase, the star becomes much larger and cooler than it was in its prime. Eventually, the red giant becomes unstable and begins to expel its outer layers of gas and dust. This material forms a shell around the star, which is then illuminated by the star's remaining core. This is how planetary nebulae are formed. The Boomerang Nebula is a preplanetary nebula because the star is still in the process of ejecting its material, and the nebula is not yet fully formed. The reason the Boomerang Nebula is so cold is due to the extremely rapid expansion of the gas being ejected from the star. As the gas expands, it cools down, similar to how an aerosol can feel cold when you spray it. In the case of the Boomerang Nebula, the gas is expanding much faster than in typical planetary nebulae, leading to the exceptionally low temperature. Astronomers have estimated that the gas in the Boomerang Nebula is expanding at a rate of over 164 kilometers per second, 367,000 miles per hour. This rapid expansion is what causes the gas to cool down to such an extreme temperature. The exact mechanism that drives this rapid expansion is still not fully understood, but it is likely related to the star's magnetic field or interactions with a companion star. The Boomerang Nebula gets its name from its distinctive shape, which resembles a boomerang when viewed through telescopes. However, more recent observations with the Atacama Large Millimeter/Submillimeter Array, ALMA, have revealed that the nebula is actually more complex than it appears. ALMA has shown that the Boomerang Nebula has a double lobe structure, with two distinct outflows of gas emanating from the central star. These outflows are not uniform. They contain knots and filaments of gas, suggesting that the ejection process is not smooth and continuous. The ALMA observations have also revealed a dense ring of dust and gas surrounding the central star, which may be channeling the outflows into the observed lobes. The Boomerang Nebula is a fascinating object that provides insights into the final stages of stellar evolution. It demonstrates the complex processes that occur as stars like our Sun transition into planetary nebulae. The extreme cold of the nebula also poses a challenge to our understanding of physics, as it pushes the boundaries of what we know about the behavior of matter at low temperatures. Studying the Boomerang Nebula helps astronomers understand the life cycle of stars, the formation of planetary nebulae, and the physics of extreme environments. It's a cosmic laboratory where we can test our theories and learn more about the universe. The Boomerang Nebula is the coldest known natural place in the universe, colder even than the cosmic microwave background. Its extreme temperature is due to the rapid expansion of gas being ejected from a dying star. It's a preplanetary nebula, offering a glimpse into the final stages of stellar evolution and pushing the boundaries of our understanding of physics. It's like nature's deep freeze, a chilling reminder of the dramatic changes stars undergo as they age. Fact 9. The metallic hydrogen of Jupiter, a superconducting core. Jupiter, the solar system's largest planet, is a gas giant, primarily composed of hydrogen and helium. However, deep within its crushing interior, the immense pressure transforms hydrogen into a bizarre and exotic state: metallic hydrogen. This strange substance is thought to play a crucial role in generating Jupiter's powerful magnetic field, the strongest of any planet in the solar system. Under normal conditions, hydrogen is a gas. But at pressures exceeding 1 million times Earth's atmosphere pressure, hydrogen atoms are squeezed so tightly together that their electrons are forced to detach from their nuclei and move freely throughout the material. This creates a state of matter where hydrogen behaves like a metal, conducting electricity with remarkable efficiency. The existence of metallic hydrogen was first predicted in 1935 by physicists Eugene Wigner and Hillard Bell Huntington. However, it was not until 2017 that scientists were able to create metallic hydrogen in a laboratory setting, using extremely high-pressure diamond-anvil cells. The conditions required to create metallic hydrogen are so extreme that they can only be found in the interiors of giant planets like Jupiter and Saturn. The pressure at Jupiter's core is estimated to be around 40 million times Earth's atmospheric pressure. Metallic hydrogen is thought to be a liquid at the temperatures found in Jupiter's interior. This liquid metallic hydrogen is an excellent conductor of electricity, and its motion within Jupiter's interior generates a powerful magnetic field through a process known as the dynamo effect. Jupiter's magnetic field is about 20,000 times stronger than Earth's magnetic field. It extends millions of kilometers into space, forming a vast magnetosphere that shields Jupiter from the solar wind, a stream of charged particles emitted by the sun. The interaction between Jupiter's magnetosphere and the solar wind creates spectacular auroras at Jupiter's poles. These auroras are much more powerful and complex than Earth's auroras. The study of Jupiter's magnetic field and interior is an important area of research in planetary science. Missions like NASA's Juno spacecraft are providing new insights into the structure and dynamics of Jupiter's metallic hydrogen core. Understanding the properties of metallic hydrogen is also important for understanding the interiors of other giant planets, both in our solar system and around other stars. It may even be possible to create metallic hydrogen on Earth in the future, which could have a wide range of technological applications, such as in high-speed electronics and energy storage. Deep within Jupiter, extreme pressure transforms hydrogen into metallic hydrogen, a highly conductive liquid. Its motion generates Jupiter's powerful magnetic field. The Juno mission is providing new insights into this exotic material. It's like Jupiter has a hidden superconducting core, generating a magnetic field that protects the entire planet. Fact 10. The Event Horizon Telescope, imaging the unseeable. Black holes, those enigmatic objects in space with gravity so intense that nothing, not even light, can escape, have long been a subject of fascination and mystery. For decades, their existence was largely theoretical, based on the predictions of Einstein's theory of general relativity. However, in 2019, the Event Horizon Telescope, EHD, collaboration achieved a groundbreaking feat, capturing the first ever image of a black hole. The Event Horizon Telescope is not a single telescope, but rather a global network of telescopes located around the world. These telescopes are linked together using a technique called Very Long Baseline Interferometry, VLBI, which allows them to function as a single Earth-sized telescope. The EHD targeted two black holes for observation: Sagittarius A-, the supermassive black hole at the center of our Milky Way galaxy, and M87-, the supermassive black hole at the center of the galaxy, Messier 87. Imaging a black hole is an incredibly challenging task. Black holes are extremely small and distant, and they do not emit any light of their own. However, the EHD was able to image the shadow of the black hole, which is the region of space around the black hole where light is bent and distorted by its intense gravity. The image of M87 revealed a bright ring of light surrounding a dark central region. The bright ring is formed by photons of light that are orbiting the black hole. The dark central region is the black hole shadow, which is the region of space from which no light can escape. The EHD's observations of M87 provided strong evidence for the existence of black holes and confirmed many of the predictions of general relativity. The size and shape of the black hole's shadow were consistent with the theoretical predictions. The EHD is continuing to observe black holes and to develop new techniques for imaging these enigmatic objects. Future observations may reveal even more details about the structure and dynamics of black holes. The Event Horizon Telescope is a global network of telescopes that captured the first ever image of a black hole, M87. The image shows a bright ring of light surrounding a dark shadow, confirming predictions of general relativity. It's like giving sight to the unseen, revealing the edge of an object from which nothing can escape. Fact 11. The James Webb Space Telescope, unveiling the infant universe. The James Webb Space Telescope, JWST, launched in December 2021, is the most powerful space telescope ever built. It's designed to peer deeper into the universe than ever before, observing the faintest and most distant galaxies and providing unprecedented insights into the formation and evolution of galaxies, stars, and planets. Unlike its predecessor, the Hubble Space Telescope, which primarily observes in visible and ultraviolet light, JWST observes primarily in the infrared. This allows it to see through dust clouds that obscure visible light, revealing objects that would otherwise be hidden from view. JWST has a much larger mirror than Hubble, with a diameter of 5 meters, 3 feet, compared to Hubble's 4 meters, 9 feet. This larger mirror allows JWST to collect more light, enabling it to see fainter and more distant objects. One of JWST's primary goals is to study the first galaxies that formed in the early universe, just a few 100 million years after the Big Bang. These galaxies are so far away that their light has been stretched by the expansion of the universe, shifting it into the infrared part of the spectrum. By studying these early galaxies, JWST will help astronomers understand how galaxies formed and evolved over time. It will also provide clues about the nature of the first stars and the conditions that existed in the early universe. JWST is also being used to study the formation of stars and planets. It can observe the clouds of gas and dust where stars are born, revealing the processes that lead to the formation of new stars. It can also study the disks of gas and dust that surround young stars, where planets are forming. JWST's observations of exoplanets, planets orbiting other stars, are helping astronomers understand the diversity of planetary systems and the potential for life beyond Earth. It can analyze the atmospheres of exoplanets, searching for signs of water, methane, and other molecules that could indicate the presence of life. The James Webb Space Telescope is the most powerful space telescope, observing in infrared to see the faintest and most distant galaxies. It studies the formation of galaxies, stars, and planets, and analyzes exoplanet atmospheres for signs of life. It's like having a time machine that lets us peer back to the dawn of the universe and search for new worlds. Fact 12. The Great Filter. The Great Filter is a concept that attempts to explain the Fermi paradox, the contradiction between the high probability of extraterrestrial life and the lack of evidence for it. The Great Filter suggests that there is some stage in the development of life, from its initial formation to becoming a spacefaring civilization, that is extremely difficult, if not impossible, to overcome. The Great Filter could be behind us, meaning that we have already overcome the difficult steps that prevents most life from becoming advanced. This would be good news for humanity, as it would suggest that we are likely to continue to progress and eventually become a spacefaring civilization. However, the Great Filter could also be ahead of us, meaning that there is some challenge that we have not yet encountered that will likely prevent us from reaching the stars. This would be bad news for humanity, as it would suggest that we are doomed to extinction. Some possible great filters include the origin of life. The formation of life from non-living matter is a complex and poorly understood process. It is possible that this is an extremely rare event, and that most planets are simply unable to produce life. The evolution of complex life. Even if life is common, the evolution of complex, multicellular life may be a rare event. It is possible that there are some fundamental barriers that prevent simple organisms from becoming more complex. The development of intelligence. The evolution of intelligence may be another rare event. It is possible that there are some inherent limitations to the complexity of brains, or that intelligence is simply not advantageous in most environments. The development of technology. Even if a civilization develops intelligence, it may not develop the technology necessary to become a spacefaring civilization. It is possible that there are some technological barriers that are difficult or impossible to overcome. Self-destruction. Even if a civilization develops the technology to become a spacefaring civilization, it may destroy itself through war, environmental destruction, or some other means. The Great Filter is a sobering concept that forces us to confront the challenges that lie ahead of us. It reminds us that we're not guaranteed to succeed as a species, and that we must work hard to overcome the obstacles that stand in our way. The Great Filter is a hypothetical barrier preventing life from advancing to a spacefaring civilization. It could be behind us good, or ahead potentially bad. Possible filters include the origin of life, complex life, intelligence, technology, or self-destruction. It's like a cosmic obstacle course with a dangerous hurdle that may doom many civilizations. Fact 13. The possible Planet 9, a gravitational perturber in the outer solar system. For years, astronomers have observed strange clustering patterns in the orbits of certain Kuiper belt objects, KBOs, icy bodies beyond Neptune. These patterns suggest that a massive, unseen object may be gravitationally influencing their movements. This hypothetical object has been dubbed Planet 9, and its existence is one of the most exciting and debated topics in planetary science today. The evidence for Planet 9 is based on the peculiar orbits of several KBOs that have highly elongated and aligned orbits. These KBOs also have orbits that are tilted significantly out of the plane of the solar system, a characteristic that is difficult to explain with the current known planetary configuration. In 2016, astronomers Konstantin Batygin and Michael Brown published a paper in the Astronomical Journal that presented compelling evidence for the existence of Planet 9. They showed that the orbits of 6 known KBOs were clustered in a way that could be explained by the gravitational influence of a massive planet orbiting far beyond Neptune. According to Batygin and Brown's calculations, Planet 9 would have a mass of about 5 to 10 times that of Earth and a highly eccentric orbit that takes it as far as 400 to 800 astronomical units, AU, from the Sun. 1 AU is the distance between Earth and the Sun. Its orbital period would be thousands of years. The existence of Planet 9 would explain not only the clustering of KBO orbits, but also the tilted orbits of some other objects in the outer solar system. It would also help to explain the existence of a gap in the distribution of KBOs at a certain distance from the Sun. Despite the compelling evidence, the existence of Planet 9 has not yet been confirmed. No such planet has ever been directly observed. The search for Planet 9 is a challenging task, as it would be very faint and located in a remote and poorly explored region of the solar system. Astronomers are using a variety of telescopes and techniques to search for Planet 9, including the Subaru telescope, the Very Large Telescope, and the Atacama Large Millimeter/Submillimeter Array, ALMA. They are also using computer simulations to refine their predictions of Planet 9's orbit and location. If Planet 9 does exist, it would have a profound impact on our understanding of the solar system. It would challenge our current theories of planet formation and evolution, and it would raise new questions about the origin and dynamics of the outer solar system. Some scientists have even suggested that Planet 9 may have been captured from another star system. This could have happened if the Sun passed close to another star early in its history. Whether Planet 9 exists or not, the search for it is a valuable endeavor that is pushing the boundaries of our knowledge of the solar system. It is a reminder that there are still many mysteries waiting to be uncovered in our cosmic backyard. Planet 9 is a hypothetical large planet in the outer solar system, proposed to explain the unusual orbits of Kuiper Belt objects. Despite compelling evidence, it hasn't been directly observed, but the search continues, potentially revolutionizing our understanding of the solar system. It's like a cosmic game of hide and seek, with a potentially massive prize hidden in the solar system's far reaches. Fact 14. The Miller-Urey Experiment, Simulating Life's Origins. One of the most fundamental questions in science is how life originated on Earth. In 1952, Stanley Miller and Harold Urey conducted a landmark experiment that provided the first experimental evidence that the building blocks of life could have formed spontaneously on early Earth. The Miller-Urey experiment simulated the conditions that were thought to exist on early Earth. They created a closed system that contained water, methane, ammonia, and hydrogen, which were believed to be the main components of Earth's early atmosphere. They then subjected the mixture to electrical sparks, which were meant to simulate lightning. After a week of continuous operation, Miller and Urey analyzed the contents of the flask. They found that a variety of organic molecules had formed, including amino acids, the building blocks of proteins. The Miller-Urey experiment was a groundbreaking achievement. It demonstrated that the basic building blocks of life could have formed spontaneously from simple inorganic molecules under the conditions that existed on early Earth. While the Miller-Urey experiment did not prove that life originated in this way, it provided a plausible mechanism for the formation of the building blocks of life. It also stimulated a great deal of further research into the origin of life. Since the Miller-Urey experiment, scientists have conducted many other experiments that have simulated different aspects of early Earth. These experiments have shown that a wide variety of organic molecules can form spontaneously under a variety of conditions. The Miller-Urey experiment is a classic example of scientific inquiry. It shows how scientists can use experiments to test hypotheses about the natural world and to gain new insights into the mysteries of the universe. The Miller-Urey experiment simulated early Earth conditions, producing amino acids from inorganic molecules. It was a landmark demonstration of how life's building blocks could have formed spontaneously. It's like recreating the primordial soup in a lab, demonstrating how the ingredients for life could have arisen naturally. Fact 15, the WOW. Signal. The WOW. Signal is one of the most intriguing and debated events in the history of the search for extraterrestrial intelligence, SETI. On August 15, 1977, while using the Big Ear radio telescope at Ohio State University, astronomer Jerry Emmett detected a strong, narrowband radio signal that lasted for 72 seconds. The signal was so unusual and compelling that Emmett famously wrote, "Wow," on the computer printout. giving the signal its name. The Big Ear telescope was designed to scan the sky for radio signals at a frequency of 1420, 4056 megahertz, which is the frequency of radio waves emitted by hydrogen, the most abundant element in the universe. This frequency is considered a likely candidate for interstellar communication because it is a natural and easily recognizable frequency. Any civilization looking for other intelligent life might use this frequency as a beacon. The WOW signal was detected in the constellation Sagittarius and was extremely strong, about 30 times stronger than the background radio noise. It also had a very narrow bandwidth, meaning that it was concentrated in a very small range of frequencies. This is characteristic of a signal that is intentionally transmitted rather than a natural phenomenon. The signal's frequency was very close to the hydrogen line frequency, and it exhibited a pattern that was consistent with a signal originating from outside the Earth's atmosphere. The Big Ear telescope had 2 feed horns, each of which detected the signal at slightly different times due to the telescope's design. The signal's intensity increased gradually in one feed horn, peaked, and then decreased gradually in the other feed horn, which is exactly what would be expected if the signal originated from a distant source that was passing through the telescope's field of view. The WOW signal sparked a great deal of excitement and speculation in the SETI community. It was considered to be one of the best candidates for a genuine extraterrestrial signal ever detected. However, despite numerous attempts to redetect the signal, it has never been observed again. The failure to redetect the WOW signal has led to a number of theories about its origin. One possibility is that it was a one-time event, such as a brief burst of radio waves from a natural source. Another possibility is that it was an artifact of the telescope or the data processing system. It is also possible that the signal was transmitted by an extraterrestrial civilization, but that they're no longer transmitting or that their signal is now directed elsewhere. One of the main challenges in verifying the WOW signal is that the Big Ear telescope was a fixed instrument, meaning that it could not be pointed in a specific direction. Instead, it relied on the Earth's rotation to scan the sky. This meant that the telescope only scanned the location of the WOW signal for a brief period of time each day. Over the years, many attempts have been made to re-observe the location of the WOW signal using other radio telescopes, but none have been successful. Some astronomers have suggested that the signal may have been caused by a reflection from a piece of space debris or a military satellite. However, this explanation is considered unlikely because the signal was so strong and had such a narrow bandwidth. In 2016, astronomer Antonio Paris proposed that the WOW signal may have originated from a cloud of hydrogen gas surrounding a pair of comets that were passing through the area of the sky where the signal was detected. However, this explanation has been met with skepticism by some astronomers, who argue that the comets were not bright enough to produce a signal as strong as the WOW signal. The true origin of the WOW signal remains a mystery. It is possible that we will never know what caused it. However, the WOW signal continues to be a source of inspiration and motivation for SETI researchers, reminding them that the possibility of detecting extraterrestrial intelligence is still very real. The WOW signal is a reminder of the vastness and mystery of the universe. It is a testament to our curiosity and our desire to understand our place in the cosmos. It is a symbol of our hope that we are not alone. The WOW signal was a strong, unexplained radio signal detected in 1977 that remains one of the most intriguing events in SETI history. Despite numerous attempts, it has never been redetected, leaving its origin a mystery. It's a tantalizing glimpse of a possible extraterrestrial message, a cosmic hello that we haven't been able to answer. Fact 16. The Great Oxygenation Event. The Great Oxygenation Event, GOE, also known as the Oxygen Catastrophe or the Oxygen Revolution, was a period of dramatic change in Earth's atmosphere that occurred approximately 4 to 2.0 billion years ago during the Paleoproterozoic era. This event marked the rise of oxygen in the atmosphere, transforming Earth from a predominantly anoxic, oxygen-free environment to one with significant levels of free oxygen. Prior to the GOE, Earth's atmosphere was primarily composed of nitrogen, carbon dioxide, methane, and other gases with very little free oxygen. Life on Earth was dominated by anaerobic microorganisms, which thrived in the oxygen-poor environment. These organisms obtained energy through processes such as fermentation and anaerobic respiration, which do not require oxygen. The GOE was triggered by the evolution of cyanobacteria, a type of photosynthetic bacteria that uses sunlight to convert carbon dioxide and water into energy, releasing oxygen as a byproduct. Cyanobacteria, also known as blue-green algae, were among the first organisms to develop oxygenic photosynthesis, and they quickly became widespread in the Earth's oceans. As cyanobacteria proliferated, they began to release increasing amounts of oxygen into the atmosphere. However, the initial oxygen released by cyanobacteria was quickly consumed by reactions with reduced compounds, such as iron and methane, in the oceans and on land. This process, known as oxygen sinks, prevented oxygen levels from rising rapidly. The most significant oxygen sink was the oxidation of dissolved iron in the oceans. Iron is highly reactive with oxygen, forming iron oxides that precipitate out of the water. For hundreds of millions of years, the oceans acted as a giant sponge, soaking up oxygen and preventing it from accumulating in the atmosphere. The banded iron formations, BDEFs, layered sedimentary rocks rich in iron oxides, are a testament to this process. Eventually, the oxygen sinks became saturated and oxygen levels began to rise in the atmosphere. This had profound consequences for life on Earth. The increase in oxygen concentration led to the extinction of many anaerobic organisms, which were unable to tolerate the toxic effects of oxygen. This is why the GOE is sometimes referred to as the oxygen catastrophe. However, the rise of oxygen also paved the way for the evolution of aerobic organisms, which use oxygen to generate energy through aerobic respiration. Aerobic respiration is much more efficient than anaerobic respiration, allowing aerobic organisms to grow larger and more complex. The evolution of aerobic organisms led to the development of multicellular life, including plants and animals. The GOE also had a significant impact on Earth's climate. Oxygen reacted with methane, a potent greenhouse gas, reducing its concentration in the atmosphere. This led to a period of global cooling known as the Huronian glaciation, one of the longest and most severe ice ages in Earth's history. The Great Oxygenation Event was a pivotal moment in Earth's history, transforming the planet from a predominantly anoxic world to an oxygen-rich one. It had profound consequences for life, climate, and geology, shaping the Earth into the planet we know today. The Great Oxygenation Event was a period when cyanobacteria released significant oxygen into Earth's atmosphere, transforming it from an oxygen-poor to an oxygen-rich environment. This led to the extinction of anaerobic organisms and the rise of aerobic life, profoundly shaping Earth's biosphere and climate. It's like Earth's atmosphere underwent a dramatic makeover, fundamentally altering the course of life's evolution. Fact 17. The failed stars, brown dwarfs. In the realm of celestial objects, there exists a class of objects that blur the line between stars and planets, brown dwarfs. These failed stars are too massive to be planets, but not massive enough to sustain the nuclear fusion of hydrogen in their cores, which is the defining characteristic of true stars. Brown dwarfs are typically 13 to 80 times the mass of Jupiter. They form in a similar way to stars, from collapsing clouds of gas and dust. However, unlike stars, they never reach the critical mass required to ignite hydrogen fusion. Instead, brown dwarfs may briefly fuse deuterium, a heavier isotope of hydrogen, early in their lives. This fusion process releases a small amount of energy, causing the brown dwarf to shine faintly. However, the deuterium fuel is quickly exhausted, and the brown dwarf begins to cool and fade over time. Brown dwarfs emit most of their energy in the infrared part of the spectrum. This makes them difficult to detect with optical telescopes, but they can be observed with infrared telescopes. The first brown dwarf was discovered in 1995, and since then, hundreds of them have been identified. They are thought to be relatively common in the Milky Way galaxy, potentially outnumbering ordinary stars. Brown dwarfs are interesting objects to study because they provide a bridge between stars and planets. They can help us understand the formation and evolution of both types of objects. One of the most intriguing aspects of brown dwarfs is their atmospheres. They have relatively cool temperatures, allowing for the formation of clouds and complex molecules. Some brown dwarfs have been found to have clouds of water, methane, and even ammonia in their atmospheres. These clouds can create weather patterns similar to those seen on Jupiter and Saturn, with bands, storms, and jets. Some brown dwarfs have even been observed to have auroras, similar to the northern lights on Earth. The study of brown dwarfs is also important for understanding the search for exoplanets. Brown dwarfs can be used as test beds for developing techniques for detecting planets around other stars. In recent years, astronomers have discovered brown dwarfs with planets orbiting them. These systems are particularly interesting because they can provide insights into the formation and evolution of planetary systems around low-mass stars. Brown dwarfs are a fascinating and diverse class of objects, and they continue to be a subject of intense research. As new telescopes and techniques are developed, we are sure to learn even more about these failed stars. Brown dwarfs are celestial objects between planets and stars, lacking the mass for sustained hydrogen fusion. They emit infrared radiation and have cool atmospheres with clouds and weather patterns. They bridge the gap between stars and planets, and the study of them helps us understand exoplanets. It's like a cosmic middle child, not quite a star, not quite a planet, but fascinating in its own right. Fact 18: The Great Attractor. The universe, on the grandest of scales, isn't a static, evenly distributed void. Instead, it's a tapestry woven with filaments of galaxies, vast empty spaces, and regions of immense gravitational influence. One of the most intriguing and mysterious of these gravitational anomalies is the Great Attractor. Discovered in the 1970s, the Great Attractor is a gravitational anomaly located in the direction of the Centaurus constellation. It resides approximately 250 million light years away, hidden behind a region of space known as the Zone of Avoidance. The Zone of Avoidance is a section of the sky obscured by the Milky Way's galactic plane, making it difficult to observe objects beyond. The sheer density of stars, gas, and dust in our galaxy's disk blocks a significant amount of light from reaching us, hindering our ability to peer through and study what lies behind it. The initial observations that hinted at the existence of the Great Attractor came from studies of galaxy redshifts. Redshift is a phenomenon where light from distant galaxies is stretched, shifting towards the red end of the spectrum. This stretching occurs because the universe is expanding and galaxies are moving away from each other. The faster a galaxy is receding, the greater its redshift. However, astronomers noticed that many galaxies in our local supercluster, the Laniakea supercluster, were moving in a way that deviated from the expected Hubble flow, the general expansion of the universe. These galaxies appear to be pulled towards a specific point in space, as if a massive gravitational force were tugging them along. This deviation from the Hubble flow was the first clue that something significant was lurking behind the Zone of Avoidance. The combined gravitational pull of all the visible galaxies in our local supercluster couldn't account for the observed motions. There had to be something much larger and more massive contributing to this gravitational anomaly. The challenge in studying the Great Attractor lies in its location behind the Zone of Avoidance. Ordinary optical telescopes are severely limited in their ability to penetrate the obscuring dust and gas. However, astronomers have employed other wavelengths of light, such as infrared and X-rays, which are less affected by the Zone of Avoidance. These observations have revealed that the Great Attractor is not a single monolithic object, but rather a region of space teeming with galaxies and galaxy clusters. One of the key components of the Great Attractor is the Norma Cluster, a massive cluster of galaxies located relatively close to the center of the anomaly. The Norma Cluster is one of the most massive galaxy clusters known, containing thousands of galaxies bound together by gravity. Its immense mass contributes significantly to the gravitational pull of the Great Attractor. However, the Norma Cluster alone is not enough to fully explain the observed gravitational effects. There must be other, even more massive structures hidden behind the Zone of Avoidance. Some theories suggest the existence of a supercluster, a collection of galaxy clusters that is even larger and more massive than the Norma Cluster. This supercluster, if it exists, would be a dominant source of gravitational attraction. The Great Attractor's influence extends far beyond our local supercluster. It is believed to be one of the major gravitational centers in the larger cosmic web, a network of galaxies, filaments, and voids that spans the entire observable universe. The Laniakea supercluster, which contains our Milky Way galaxy, is itself being drawn towards the Great Attractor. Understanding the Great Attractor is crucial for understanding the large-scale structure and dynamics of the universe. It helps us map the distribution of matter in the cosmos and understand how galaxies and galaxy clusters form and evolve. It also provides insights into the nature of gravity and dark matter, the mysterious substance that makes up a significant portion of the universe's mass. The Great Attractor remains an active area of research. Astronomers continue to use advanced telescopes and techniques to probe the region behind the zone of avoidance, searching for more clues about its composition and gravitational influence. Future observations, particularly with next-generation telescopes, promise to reveal even more about this enigmatic region of space. The Great Attractor is a massive gravitational anomaly pulling galaxies, including our own, towards it from behind the obscuring zone of avoidance. It's a complex region, likely composed of massive galaxy clusters and possibly a hidden supercluster, and studying it helps us understand the structure and dynamics of the universe. It's like the universe's hidden boss, subtly influencing everything around it. Fact 19. The BL Lacerti objects, blazers cosmic beacons of destruction. Deep within the hearts of some galaxies reside supermassive black holes, millions or even billions of times the mass of our Sun. These behemoths are often surrounded by swirling disks of gas and dust called accretion disks. As matter falls into the black hole, it heats up to extreme temperatures, emitting copious amounts of radiation across the electromagnetic spectrum. In some cases, these active galactic nuclei, AGN, exhibit an even more extreme phenomenon. Powerful jets of particles and energy that shoot out from the black hole's poles at nearly the speed of light. When one of these jets happens to be pointed directly towards Earth, we observe it as a BL Lacerti object or blazer. Blazers are among the most luminous and energetic objects in the universe. Their intense emission is thought to be due to the relativistic beaming effect, where the light from the jet is amplified and compressed in the direction of motion. This beaming effect makes blazers appear much brighter than they would if their jets were pointed in a different direction. The name BL Lacerti object comes from the first object of this type to be discovered, BL Lacerti. Initially, BL Lacerti was thought to be a variable star within our own galaxy. However, in the 1960s, astronomers realized that it was actually a distant galaxy with a supermassive black hole at its center. Blazers are characterized by their rapid and dramatic variability. Their brightness can change by factors of 10 or more in a matter of hours or days. This variability is thought to be due to changes in the accretion rate onto the black hole, or to instabilities within the jet itself. Blazers emit radiation across the entire electromagnetic spectrum, from radio waves to gamma rays. The gamma ray emission is particularly interesting, as it is thought to be produced by the most energetic particles in the jet. By studying the gamma ray emission from blazers, astronomers can learn more about the acceleration mechanisms that operate in these extreme environments. Blazars are also powerful sources of cosmic rays, high-energy particles that bombard Earth from space. The origin of cosmic rays has been a long-standing mystery, but blazars are now considered to be one of the leading candidates. The jets of blazars can accelerate particles to extremely high energies, launching them into interstellar space. The study of blazars is important for understanding the formation and evolution of galaxies, the physics of black holes, and the origin of cosmic rays. They are also valuable tools for probing the intergalactic medium, the tenuous gas that fills the space between galaxies. By studying how the light from blazars is absorbed and scattered by the intergalactic medium, astronomers can learn more about its properties. Blazars are a fascinating and complex phenomenon, and they continue to be a subject of intense research. As new telescopes and techniques are developed, we are sure to learn even more about these cosmic beacons of destruction. Blazars are supermassive black holes with jets pointed directly at Earth, making them incredibly bright and variable. They emit radiation across the spectrum and are thought to be sources of cosmic rays. Studying blazars helps us understand galaxies, black holes, and the intergalactic medium. They're like cosmic lighthouses, shining intensely across vast distances as they consume everything around them. Fact 20. The Pillars of Creation. The Pillars of Creation, located in the Eagle Nebula, M16, are one of the most iconic and breathtaking images captured by the Hubble Space Telescope. These towering columns of gas and dust are actively forming stars, making them a celestial nursery where new suns are being born. The Eagle Nebula, located approximately 7,000 light-years away in the constellation Serpens, is a vast cloud of gas and dust that spans over 70 light-years. The Pillars of Creation are just a small part of this larger nebula, but they're the most visually striking and scientifically significant region. The pillars are composed primarily of hydrogen and helium, along with trace amounts of heavier elements. They are illuminated by the intense ultraviolet radiation from nearby young, hot stars. This radiation is responsible for shaping the pillars, eroding away the outer layers of gas and dust. The pillars are not solid objects. They are diffuse clouds of gas and dust that are constantly being sculpted by the forces of gravity, radiation, and stellar winds. The tallest of the pillars is about 4 light-years long, which is roughly the distance between our Sun and the nearest star, Proxima Centauri. Within the pillars, gravity is pulling together denser clumps of gas and dust. These clumps are collapsing under their own weight, forming protostars. As these protostars grow, they begin to heat up and emit their own radiation. Eventually, they will ignite nuclear fusion in their cores, becoming fully fledged stars. The pillars of creation are a dynamic and ever-changing environment. The same radiation that illuminates the pillars is also slowly destroying them. The intense ultraviolet radiation is evaporating the gas and dust, causing the pillars to shrink over time. In fact, a supernova explosion that occurred thousands of years ago has likely already destroyed the pillars of creation. However, because the Eagle Nebula is 7,000 light-years away, we are only now seeing the light from that explosion. It will take thousands of years for the light from the destroyed pillars to reach us, so we will continue to see them for a long time to come. The pillars of creation are not the only star-forming region in the Eagle Nebula. There are many other regions of active star formation throughout the nebula, including smaller pillars, globules, and Bok globules, small, dense clouds of gas and dust that are often sites of star formation. The Eagle Nebula is a rich and complex environment that provides astronomers with a unique opportunity to study the process of star formation. By studying the pillars of creation and other star-forming regions in the nebula, astronomers can learn more about how stars are born, how they evolve, and how they influence their surrounding environment. The pillars of creation are not just a beautiful image. They're a window into the process of creation itself. They show us the raw materials from which stars are made and the forces that shape them. They remind us that the universe is a dynamic and ever-changing place where new stars are constantly being born and old stars are dying. The pillars of creation are towering columns of gas and dust in the Eagle Nebula, actively forming stars. They are illuminated and shaped by intense radiation from nearby stars, which is also slowly eroding them. While a supernova may have already destroyed them, we will continue to see them for thousands of years due to the distance. They are a stunning visual representation of star formation and a reminder of the dynamic nature of the universe. It's like watching the universe's sculptors at work, carving stars out of cosmic dust. Fact 21. The Fermi Bubbles, mysterious giants above the Milky Way. Extending far above and below the plane of our Milky Way galaxy are two colossal structures known as the Fermi Bubbles. These enormous bubbles of hot gas emit intense gamma-ray radiation and span approximately 25,000 light-years each, stretching from the galactic center to well beyond the galactic disk. The Fermi Bubbles were discovered in 2010 by the Fermi Gamma Ray Space Telescope, which is designed to detect high-energy gamma rays from across the universe. The bubbles are relatively faint and were not detected until Fermi's sensitive instruments were able to map the gamma-ray sky in detail. The origin of the Fermi Bubbles is still a mystery, but the leading hypothesis is that they were caused by a massive outburst of energy from the supermassive black hole at the center of our galaxy, Sagittarius A. Sagittarius A is currently relatively quiet, but it may have been much more active in the past. Millions of years ago, it could have consumed a large amount of gas and dust, releasing a tremendous amount of energy in the form of jets of particles and radiation. These jets could have inflated the Fermi Bubbles, pushing the hot gas outward into the galactic halo. Another possibility is that the Fermi Bubbles were created by a burst of star formation in the galactic center. Massive stars can produce powerful stellar winds and supernova explosions, which can also heat and accelerate gas into the galactic halo. The Fermi Bubbles are not the only evidence of past activity in the galactic center. Astronomers have also discovered evidence of a giant outflow of gas and dust extending thousands of light years above and below the galactic plane. This outflow may be related to the Fermi Bubbles, or it may be a separate phenomenon. The Fermi Bubbles are surrounded by a faint glow of microwave radiation known as the WMAP haze. The origin of the WMAP haze is also uncertain, but it may be caused by synchrotron radiation from electrons spiraling in magnetic fields within the bubbles. The Fermi bubbles are a fascinating and enigmatic feature of our galaxy. They provide a glimpse into the past activity of the galactic center and offer clues about the processes that shape the Milky Way. The Fermi bubbles are massive gamma ray emitting structures above and below the Milky Way's plane, likely caused by an outburst from the central black hole or star formation. They offer a glimpse into the galaxy's past activity. It's like the Milky Way burped out two giant, invisible bubbles of energy into space. Fact 22. The rare Earth hypothesis. While the universe may be teeming with planets, the rare Earth hypothesis suggests that the conditions necessary for the emergence and evolution of complex life, like that on Earth, are exceptionally rare. This hypothesis, developed by Peter Ward and Donald Brownlee, doesn't deny the possibility of simple life elsewhere, but argues that the combination of factors that made Earth habitable for complex life is extraordinarily unlikely. These factors include the right distance from the Sun. Earth is located within the Sun's habitable zone, where liquid water can exist on its surface. The right size and composition. Earth is large enough to retain a substantial atmosphere and has a rocky composition with abundant water. A stable orbit and axial tilt. Earth's stable orbit and axial tilt provide relatively stable seasons, preventing extreme temperature variations. A large moon. Earth's large moon stabilizes its axial tilt and creates tides that may have played a role in the origin of life. Plate tectonics. Earth's plate tectonics help to regulate the planet's temperature and recycle nutrients. A global magnetic field. Earth's magnetic field protects it from harmful solar radiation. The presence of Jupiter. Jupiter, acting as a cosmic vacuum cleaner, has shielded Earth from many potentially catastrophic asteroid and comet impacts. A relatively quiet galactic neighborhood. Earth is located in a relatively quiet region of the Milky Way galaxy, away from the intense radiation and gravitational disturbances of the galactic center. The rare Earth hypothesis suggests that the combination of all these factors is so unlikely that Earth may be one of the few planets in the universe that is capable of supporting complex life. If the rare Earth hypothesis is correct, it would have profound implications for the search for extraterrestrial life. It would suggest that we should focus our efforts on searching for signs of simple life, rather than complex life. It would also suggest that we should be cautious about assuming that other planets are similar to Earth. The rare Earth hypothesis argues that the combination of factors making Earth habitable for complex life is extremely rare. These include its position, size, moon, plate tectonics, and Jupiter's protection. If correct, it implies complex life may be scarce. It's like winning a cosmic lottery with a series of incredibly improbable events that aligned perfectly to create our unique world. Fact 23. The Dyson Sphere and the search for megastructures. Imagine a civilization so advanced that it has exhausted the energy resources of its home planet. What would it do? One theoretical solution, proposed by physicist Freeman Dyson in 1960, is to build a megastructure that completely surrounds its star, capturing nearly all of its energy output. This hypothetical structure is known as a Dyson sphere, though Dyson himself initially envisioned a Dyson swarm of independent orbiting collectors. The basic concept is to create a vast array of solar collectors, habitats, and other structures that orbit a star, forming a shell or swarm around it. This would allow the civilization to harness an immense amount of energy, far beyond what could be obtained from its planet alone. The energy could then be used to power advanced technologies, such as interstellar travel, terraforming, or even the creation of artificial universes. Dyson himself didn't necessarily believe that Dyson spheres were likely to exist, but he argued that searching for them could be a fruitful way to detect advanced extraterrestrial civilizations. The basic idea is that a Dyson sphere would block a significant portion of the star's visible light, re-radiating it as infrared radiation. By searching for stars with unusual infrared emissions, we might be able to detect the presence of a Dyson sphere. The search for Dyson spheres and other megastructures has become a part of the broader search for extraterrestrial intelligence, SETI. Astronomers have been scouring the skies for stars with unusual spectral signatures, looking for signs of artificial construction. However, the search has been challenging, as many natural phenomena can also produce similar infrared emissions. One of the most intriguing candidates for a partial Dyson sphere was the star KIC 846 2852, also known as Tabby star or Boyajian star. This star exhibited unusual and irregular dimming events, with its brightness decreasing by as much as 22% at times. This was unlike anything seen in other stars, and it sparked a flurry of speculation about the possibility of an alien megastructure. Some scientists propose that the dimming events could be caused by a swarm of comets passing in front of the star. Others suggested that they could be caused by a large, irregularly shaped object orbiting the star, such as a planet with a massive ring system. However, the most exciting possibility was that they could be caused by a partially constructed Dyson sphere or some other type of alien megastructure. Unfortunately, further observations of Tabby's star have revealed that the dimming events are likely caused by dust rather than an alien megastructure. The dust could be the result of a collision between asteroids or comets in the star's planetary system. While this explanation is less exciting than the Dyson sphere hypothesis, it is more consistent with the available evidence. Despite the lack of conclusive evidence for Dyson spheres, the search for megastructures continues to be a valuable part of SETI. It forces us to think creatively about the possibilities for extraterrestrial technology and to develop new methods for detecting alien civilizations. Even if we never find a Dyson sphere, the search itself can lead to valuable discoveries about the universe. The concept of the Dyson sphere also raises profound questions about the future of humanity. As our civilization continues to grow and consume more energy, we may eventually need to consider building our own megastructures to meet our energy needs. While building a full-scale Dyson sphere is beyond our current technological capabilities, smaller-scale megastructures, such as solar power satellites, could become a reality in the future. The Dyson sphere is a powerful symbol of the potential for technological advancement and the boundless possibilities of the universe. It is a reminder that anything is possible and that the only limit is our imagination. The Dyson sphere is a hypothetical megastructure built around a star to harness its energy. While no definitive evidence exists, the search for these structures continues as part of SETI. Tabby's star was a promising candidate, but dust is the more likely cause of its dimming. It's a fascinating concept that explores the potential of advanced civilizations and our own future energy needs. It's like a cosmic power plant capturing the full potential of a star's energy. Fact 24. The Great Gamma Ray Bursts. Cosmic explosions of unimaginable power. Among the most energetic and luminous events in the universe are gamma ray bursts, GRBs. These are brief but intense flashes of gamma rays, the most energetic form of electromagnetic radiation. GRBs can release more energy in a matter of seconds than the sun will release in its entire 10 billion year lifetime. Gamma ray bursts were first discovered in the late 1960s by the Vela satellites, which were designed to detect nuclear weapons testing in space. However, it soon became clear that GRBs were not caused by human activity, but rather by powerful cosmic events. For many years, the origin of GRBs was a mystery. However, in the 1990s, astronomers were able to identify the afterglows of GRBs in other wavelengths of light, such as X-rays, visible light, and radio waves. This allowed them to determine the distances to GRBs and to study their host galaxies. It is now known that there are two main types of GRBs: long-duration GRBs and short-duration GRBs. Long-duration GRBs, which last for more than 2 seconds, are associated with the deaths of massive stars. When a massive star runs out of fuel, its core collapses to form a black hole. As the black hole forms, it releases a tremendous amount of energy in the form of jets of particles and radiation. These jets can pierce through the star and escape into space, producing a GRB. Short-duration GRBs, which last for less than 2 seconds, are thought to be caused by the mergers of neutron stars or the merger of a neutron star and a black hole. These mergers release a tremendous amount of energy in the form of gravitational waves and electromagnetic radiation, including gamma rays. Gamma ray bursts are extremely rare events. A typical galaxy experiences only a few GRBs per million years. However, because GRBs are so luminous, they can be detected from billions of light years away. GRBs are valuable tools for studying the early universe. Because they're so bright, they can be used to probe the intergalactic medium, the gas that fills the space between galaxies. They can also be used to study the formation and evolution of galaxies. Gamma ray bursts, GRBs, are the most energetic events in the universe, releasing vast amounts of energy in seconds. Long-duration GRBs are from the deaths of massive stars, while short-duration GRBs are from mergers of neutron stars or black holes. They help us study the early universe. It's like the universe letting out an incredibly powerful, fleeting scream, revealing secrets of the cosmos.